All right, hello again, fifth graders. Today we're going to be focused on page 583 in your packet. Okay, I'm going to write it right down here, page 583. Okay, if you don't have your packet, once again, you can use the digital pages. I would love it if you guys were be able to follow along with me on a pencil and paper. That might be the most productive. Okay, so we've learned about different ways of classifying polygons. Remember, polygons are just flat. They are flat shapes with sides and angles. That's about as general as we possibly can. Now we know that we have really general polygons, and then we have really specific polygons. So a general polygon might be, let's say, a quadrilateral, any shape with four sides. And more specific, a really specific polygon might be a square because it has four sides, two sets of parallel sides, four right angles, as well as all four sides are of equal length. That's really specific. I just listed off four attributes. For quadrilaterals, it just has one. So last two videos, we've gone from really general to really specific, and we're going to continue that trend in different ways of classifying and categorizing different two-dimensional figures. So number one, it says, a regular polygon has all sides of equal length and all angles of equal measure. Okay, so we're kind of trying to figure out what polygon are they explaining. Okay? So it says, which shape below are subcategories of regular polygons? And then it asks us to even explain. Okay? So I'm going to tell you right now there's two. Okay? So it says, a regular polygon has all sides of equal length and all angles of equal measure. So of the four, there are two correct answers. We have squares, pentagons, equilateral triangles, and hexagons. I'm going to give you a second. You pick yours at home. Okay? Hopefully this is what you got. Squares and equilateral triangles. But why? Well, it actually seems a little bit more obvious now that we read the definition again. A regular polygon has all sides of equal length. Now I said it in our intro. What's a square? What's its last attribute that makes it a square? All four sides of equal length. Then in the equilateral triangle, although it only has three sides, it doesn't matter. Are the three sides of equal length? Yes. And in the equilateral triangle, if all three sides are equal length, that means all three angles are of equal measure. And same thing goes for squares because all angles are 90-degree angles. Fair enough? And that's what I would say in my description. Equilateral triangle has all three sides of equal length, and square has all four sides of equal length. Alright, moving on to number two. Alright guys, it says a tree diagram can use two lines to show subcategories that do not overlap. So, Jose drew these two diagrams to show how categories of triangles are related. Are his diagrams correct? Explain. So we're thinking about triangles, okay? So triangles is of the broadest categories, and that meaning it only has three sides. Fair enough. Now we have two lines branched off of triangles. Now on the left side is one category by itself, and that's scaling. And scaling is kind of by itself because a scaling triangle just has three sides, and all three sides are different lengths. That's why it would be by itself. Now, off to the right, we have branched and isosceles and equilateral. Okay, well, let's think about this. Isosceles has two sides of equal length. Equilateral triangle has three sides of equal length. So those could be categorized together because we went from most general of the two sides being the same length to the most specific, three sides of equal length. So let's see if our Venn diagram relates to our tree diagram. We're looking over here. Broadest is the three-sided figure, which is a triangle. Scaling by itself because all three sides are of different length. Isosceles is the next broadest because it has two sides of equal length, and the equilateral triangle is the most specific and it is our center of our Venn diagram because all three sides have equal length. So every equilateral triangle is an isosceles, but not every isosceles is an equilateral triangle. Would you agree with Jose's Venn diagram and tree diagram? I would. I think it's put together perfectly. Because an equilateral triangle is a subcategory of isosceles triangle because they have at least two equal sides, right? But if you did it vice versa, it wouldn't be necessarily correct. All right? I agree with Jose. Moving on. Okay, it says create. Describe the attributes of a shape that is both a rectangle and a rhombus. Name the shape and use the grid to draw an example. So, a rectangle I know has to have 4 sides, has to have 2 sets of parallel sides, and has to have 4 right angles. Okay? Now a rhombus has to have 4 sides, 2 sets of parallel sides, as well as 4 equal length sides. Now you'll notice there's one attribute missing from the rhombus that a rectangle has, and that is 4 right angles. So what's a combination of those two? Well, let's see. How about a square? Now let's check out if a square matches up with all the attributes of a rectangle and a rhombus. Okay, let's start with the rectangle. Has 4 sides. Bingo. Check. There's one. Okay, does it have 4 right angles? Check. Does it have 2 sets of parallel sides? Check. And does it have at least 2 sides of equal length? Well, in a square, all 4 sides are equal length. So I can say, once again, check. Now let's think about the rhombus. Okay, let's check out the different attributes of the rhombus. Does it have 4 sides? Check. Okay. Does it have 2 sets of parallel sides? Check. And does it have all 4 sides of equal length? 1, 2, 3, 4, all 3 square units. Check. So a mixture of a rhombus and a rectangle would be a square. Alright guys, that's all I have for you today. Okay, I hope this was helpful for your practice page on page 584 as well as 585. Alright guys, have a good rest of your day.